My dear friends, welcome to Rajashekhar classes on Applied Data Science with Python. This is lecture number 305. In this lecture, we will try to understand multi-class classifier. So, we have seen a binary classifier. A binary classifier is a classifier wherein your yi belongs to 0, 1 because you have only two classes, that is 0 class and 1 class. A multi-class classifier on the other hand, basically your yi belongs to, let me say 0, 1, 2, so on 9. Just try to recall, I already discussed a data set known as MNIST data set, wherein a given image we have to determine whether it is 0 digit image, whether it is 1 digit image, whether it is 2 digit image, whether it is 0 image, 1 image, 2 image, so on 9 image. I already discussed about this particular data set in detailed manner in my previous lectures. Here you have, how many classes do you have here? Here you have 10 classes, isn't it? How many classes? We have 10 classes. No more 2 classes. Now, some classification algorithms can do multi-class classification automatically, and some classification algorithms can do only binary classification. If you take our KNN, if you consider our KNN, the classifier that we already learned, it can do multi-class classification very naturally. For example, imagine, let me assume my data set is, let me say this is dn. dn equal to xi comma yi such that xi belongs to rd, your yi belongs to 1, 2, so on c. Just consider this one. This is a data set dn. If you notice here, I have C classes, just see first class, second class, third class. How many classes do I have here? I have C classes. My yi can belong to any of these C classes. So this is called a C class classification problem. When I have that, how does KNN exactly works? Given a query point xq, let me say this xq is my query point. Let it be, let this xq is query point. Let's say I am doing 7 nearest neighbor. Let me say I am doing 7nn, let me assume. And let's assume I have C classes. Just see how many classes I have here. I have C classes. I have class 1, class 2, class 3, so on class C. This is class 1, class 2, class 3, so on. Let me say I have C classes. As I told you, I am considering 7 nearest neighbors. I ask myself, for xq, how many points among the 7 nearest neighbors belongs to class 1? Let's assume none of the points belongs to class 1. If none of the points belongs to class 1, in that 7 nearest neighbors, I can say in the place of class 1, I can keep 0. Let's assume 6 points belongs to class 2. Then I can keep 6 here, isn't it? 1 point belongs to class 3. Let it be 1 point belongs to class 3. Isn't it? Rest everything is 0. Why? Because we are considering only 7 nearest neighbors. Now I know xq belongs to either class 2, or class 3, isn't it? Either class 2 or class 3. Why? Because in class 2 there are 6 neighbors related to class 2. There is one neighbor related to class 3. If I use, what is the basic concept in k nearest neighborhood algorithm? Majority voting. This is the basic idea behind this k nearest neighborhood algorithm. If I use a simple majority voting scheme, I will declare my YQ. My YQ is class 2. What is the reason? Basically, class 2 has a majority of points. If I use 7 nearest neighborhoods, 6 of the nearest neighbors belongs to class 2 and only one of them belongs to class 3. So, if I use majority vote concept, my YQ is equal to class 2. If I use a probabilistic classifier, if I give probability value, how can I give? Just see, probability of YQ is equal to 2. What is that probability? YQ equal to how many possibilities? Favorable 6, total 7, 6 by 7. What about the probability of YQ equal to 3? YQ equal to 3, there is only one possibility, therefore I can say it is 1 by 7. Then what about other probabilities? Probability of YQ equal to 1 is equal to 0, which is equal to probability of YQ equal to 4, YQ equal to so on, probability of YQ equal to C. All other probabilities is equal to 0. Why? Because there are no favorable cases. You have favorable cases only for class 2 and class 3. If I want to give probabilistic class, if I want to build probabilistic classifier, I can use this one. I can use this probabilities to build probabilistic classifier. So, KNN, because it uses majority rule or probabilistic method like this, we can easily do multi-class classification. So, KNN, I can write, so your KNN. So, KNN can easily be extended. Can easily be extended to multi-class classification. I can easily extend KNN to do multi-class classification, but in the future classes, when we learn other techniques like logistic regression, we will learn that they are fundamentally binary classifiers. Which one is fundamentally is binary classifier? Your logistic regression. I will discuss about logistic regression. I already discussed about logistic regression, but still I will spend some time on this particular technique. This is basically fundamentally, logistic regression is fundamentally is a binary classifier. They cannot do multi-class classification as easily as KNN. Now the question here is, there are some classifiers like KNN which can do multi-class classification very easily. Given a multi-class classification problem, can we convert? Let me write otherwise question. Let me say like this, given a multi-class classification problem, a multi-class classification problem, given a multi-class classification problem, can we convert it into binary classification problem? That is our question. Binary classification problem. This is our question, isn't it? Here we can do, how can I do it? Now let's see, given multi-class classification problem. Just remember this question, how this question is useful. We will try to analyze. Just see this one. Now let's see, given a multi-class classification problem, imagine my yi belongs to 1, 2, so on C. Isn't it? Imagine you have a data set. Let me say yi belongs to 1, 2, C. Imagine you have a data set. Let me say I have a data set Dn, which has your yi's belongs to multiple classes, I can say. Let me say your yi belongs to multiple classes like 1, 2, so on C. Now if you want to convert it into binary classifier, we can do it as follows. We can build our first classifier which says, let's break this Dn into 2 parts. Let's break this Dn into 2 parts. Let me say my Dn is first part xi, yi, such that your yi is equal to 1. That is my first part. What about my second part? I have xi, yi, such that yi is not equal to 1. Yi is not equal to 1. Now what happens? Now I have 2 classes. So I broke up Dn into 2 parts. One part where all of my points which belongs to class 1, all of the points which do not belongs to class 1. Now all the points which belongs to class 1, call it as positive points. All the points which do not belongs to class 1, I will call it as negative class. So that, let me say this is my positive class. Let me say this is my negative class. Now from problem where I have C, now from a problem where I have C classes, let's take class 1 as one class, rest of them as other class. Now I can build a binary classifier here to predict whether it is 1 or not. Whether it is 1 or not, isn't it? Whether it is 1 or not. That's what this binary classifier does. This is, let me say this is first one. In similar manner, let me say again take Dn, break it up into 2 parts. Let me break this Dn into 2 parts. How can I break it? First one, yi belongs to 2. Second one, yi is not belongs to 2. Again it is a binary classifier. Again it is binary classifier. Binary classifier, isn't it? Now I can create binary classifier. In this binary classifier, 2 or not 2. What is the case? This is 2 or not 2 class. This is 1 or not 1 case, isn't it? In similar manner, let me say now I can do it again. Your data set Dn, I am breaking this data set Dn into yi equal to 3 is one class and yi is not equal to 3 is another class. Again it is binary classifier. Again it is binary classifier, isn't it? You can continue this procedure, isn't it? As it now similarly, if I have C classes, how many classes I have here? I have C classes here. I can build in similar manner. I can build C binary classifiers. C binary classifiers, isn't it? Each binary classifier will say whether class 1 or not, whether class 2 or whether class 1 or not 1, whether class 2 or not 2, whether class 3 or not 3, whether class C or not C. That's what each of these classifier will do, which means given a multi-class problem, given a multi-class classification problem with C classes, I can convert this into C binary classification problems of 1 or not 1, 2 are not 2, 3 are not 3, I can say C are not C. I can say this is multi-class, let me write multi-class classification problem. Multi-class classification problem, isn't it? What we are doing here, how many classifiers one can build? C binary, I can say C binary classification problems. C binary, I am converting this multi-class classification problem into C binary classification problems, isn't it? Of course, you are going to train C models here. You are going to train C binary classifiers. Each classification problem results in one function. So, you will train one function f1x corresponding to class 1, isn't it? Which says whether it is class 1 or not. We will train other function f2x which says whether it is class 2 or not. So on so forth. Fc of x says class C or not C. This is very useful. I can write it as what is my f1x? f1x says class 1 or not. Class 1 or not. This is class 1 or not. In similar manner, f2x, my f2x class 2 or not, isn't it? In similar manner, fcx is class C or not. Now we are using data set Dn to convert multi-class classification problem to C binary classification problems, isn't it? f1x, f2x, so on, fcx. We solve each of these problems. Very graceful solution. This solution is called one versus rest. Because in each case one or not. In each case one or not one, isn't it? That is one versus rest of the class. One versus rest of the class. In similar manner, two or not two. Two versus rest of the classes. In similar manner, three or not three. That is three versus rest of the class, isn't it? So on so forth, isn't it? C versus rest of the classes. If I keep on continue, C versus rest of the classes. Rest of the classes, isn't it? Rest of the classes. So this technique is called one versus rest to do multi-class classification. And when we have multi-class classification, one versus rest is very simple technique. Of course, the time complexity and space complexity will increase because you are training C classifiers. Some classification algorithms like k nearest neighborhood can easily be extended to multi-class classification. Other classification algorithms like linear regression may not be easily extended. In my next class, I will continue my discussion on k nearest neighborhood algorithm with the distance measure. Thank you very much.